Okay, one of you confirm, please, if you can see my screen. Super. Okay, this is a very small notebook that I'm going to share with you guys. It has the codes for the feature extraction. I hope you guys have studied all the resources. I have given you more than enough time to do that. It's been, I think, 5 days since I gave the all the resources the for all the features in the audio, and then on 20th I gave you the resources of on how to extract those features. Okay, so I believe all of you have gone through it. It's been too many days since that happened. Okay, so as always, the first thing you're going to do is import all your libraries. Librosa is the library that we'll use. It is the library that is used for audio analysis. Okay, display is just one more thing you import with Librosa. Sound file, it is not necessary to import that. Matplotlib you have done for all the graphs, you need this library. IPython is a library that is used to display these interactive medias. Okay, I'll show you what interactive rich media looks like. And NumPy we have already done, right? Since if you have studied the resources, you know that there are going to be some calculations involved, and all the calculations are done using NumPy. All right. Okay, so as always, go to file, upload your files. I already have two of these audio files that I have imported. So you add them to audio 1 and 2. I'll run all of these libraries first. Okay, and then the first thing you extract from any audio is this Y and SR. Y is this NumPy array of audio signals. Okay, the signals are not, if you see a signal, you won't find a number. Okay, it is a wave or something like that, right? So what Librosa does is it converts those audio signals into a NumPy array. Okay, and then you can perform all your calculations on those numbers and get a new signal from that. Okay, or anything you want, any feature you want, it can be extracted from that. So this is what Librosa does whenever you load an audio in it. So this is one feature it extracts, and then there is the sample rate, SR. Okay, so you find those values from your audio. And okay, see, this is IPython. Okay, I told you now this is used for to display interactive rich media. If you do that, if you use IPython for an audio, it will display your audio. Okay, it says 9. Could you hear it? I'm waiting for a reply. Why are you guys so slow in responding with a yes or no? Could you hear the audio? Should I play it once again? Could you hear it? Okay, no problem. I'll have to share the audio as well. Okay. When I give you this notebook and you play this, you will be able to hear it. It just plays the audio, whatever your audio is. IPython will display it like this. And when you click on play, you can play it and you can like adjust the playback speed, okay, from normal to 2 times. All right, that is what you can do with this. This is what IPython is used for. It is not a normal thing to display. It is a rich media, okay. And that is why you need this library in particular to display it. That was your audio 2. It said 9. Okay. And this is an audio which says 2. This is from a data set for spoken numbers. Like you can use this data set to create a model which will classify the numbers, okay, based on the various audio features. Like what does 2 sound like? It will find some features, it will compare them. And when you add a new audio to this, it will predict, okay, this is the number. That is what this data set is basically used for. Okay, now there's MFCC. I gave you a very detailed explanation in the resources of what MFCC is. It is one of the extremely important parts of audio feature extraction. All right. And I think it was Ritwin who asked me what is the use of this thing, Fourier transform, right? So what happens is your audio is basically in the time domain. Okay. There are in the resources, there's also mentioned what is time domain and frequency domain. So basically what we have is the time domain data. Okay. And then what Fourier transform does it converts that time domain data into, okay, the time domain data into the frequency domain. All right. And once you have the frequency domain data, it makes it extremely easier for you to extract more features from that data. All right. If you look at MFCC, what is the full form of it? Mel frequency Kepler coefficient. Okay, the F stands for frequency, right? So frequency makes it extremely easy to extract many of the features. That is one of the main reasons we use Fourier transform. Okay, so this is how Liberosa has all the features to extract whatever data you want. If it is MFCC, all you do is liberosa.feature.mfcc, and you give this Y1 and SR1, these values, these two values that you extracted from it, to this MFCC, and then you can see it. See, this is what it is going to look like. And if you know what MFCC is, if you have read the resources, you would know what this is. Now, the other thing we have is zero crossing rate. It's pretty self-explanatory if you look at it, what is zero crossing rate is. Again, you give this your NumPy array to it, and it will extract some values from it. You can do the same thing with energy, spectral roll-off, spectral flux, this pitch, and you can create a spectrogram. Okay, spectrogram is one of the most important things here. This one is for the number 9, I think. This is for the 9 data. This is what that spectrogram looks like. And for the second audio, if you see, then this is it. Okay, you see that the lighter decibels are more here, okay, as compared to this one. Okay, and these are some of the features that you can use in order to see key, okay, this, if the spectrogram resembles more of this pattern, then maybe it's 2. And if they resemble this, maybe it's a 9. But this is not the right way to do it. This is not exactly, it does not exactly give you the right answers, because what decibels are is basically the intensity or loudness, right? So you can shout 9, you can shout 2. Okay, so this won't exactly give you the accurate results. So what we use is this MFCC values mostly. Okay. And there's the MEL spectrogram. Okay, this is a spectrogram, and this is your MEL spectrogram, which you can create for both of them. Again, this has more lighter decibels, and this one has more of the darker ones. Okay. Okay, and then there's the band energy ratio, which you should have studied in the resources. You can create that as well. If there are any other features, you can use those as well. What your assignment is going to be is that I will give you some audios, not a lot of them, some audios, but what you need to do is, okay, say I give you the audio data for the number 0. Okay, there are a lot of ways. Many people have said 0. Okay, and then I gave you the data for the number 3. Now what you need to do is you need to analyze those audios, and you need to figure out which of these can be used in order to differentiate between them. If I give you a new audio, then how will you be able to classify key, okay, this is 0 and this is 3. Okay, that is your assignment, and I'm only going to give you 2 days to do that. It's Sunday today, so today is gone. So Monday and Tuesday. So by Tuesday night, you should have done this assignment. Okay, Tuesday end of day is the last time for the submission of this assignment. All you need to do is analyze those audios, figure out key. Okay, for example, say, okay, if you look at zero crossing rate, maybe for the number zero, maybe you have all these values between 0.1 to 0.5, say. And for the number 3, you see that the values are between 0.4 to 0.7. So that is one way you can classify them. Okay, that is not generally going to be true, but maybe it is that you need to figure out which of these features you can use in order to differentiate between them. Okay, that's all your assignment is. It's not a very big assignment, should not take much of your time. And most importantly, if you see this roll percent is there, now you should know that for spectral roll off, this is 85% in general, but you can change this. And what else is there? Yeah, this number of Fourier transformations, the hop length. See, these are some attributes you see that you need to change them. You need to see how they are affecting your data, and then you create the best you can, okay, out of that. So play around with these attributes, see how you can differentiate between things. Now, if you have studied the resources again, you will see that most of these features are used in traditional machine learning methods. Okay, not the one we are going to create. But this needs to be clear in your head about what machine learning can do and how you can classify them. If you find a range, the example I gave you for zero crossing rate, if your range is from 0.1 to say 0.5, you need to write it at the end of your notebook. Okay, again, you're going to submit me a notebook, and at the end of it, you are going to add a text box, and here you are going to write the conclusion ki, okay, this is the feature we are going to use, and this is the difference we saw. If there is a range, mention that range so I can see ki, okay, what you have done is correct or not. If you only mention that, okay, there are different ranges, different pitch values, and we can use them, then no, that is not going to work. You need to give me solid, good reasons and good answers for me to be able to understand ki, okay, you have done something and you have done it well. All right, that is your assignment. And okay, I see most of you are here. Okay, your attendance has been taken, and there are 3 people who have still not submitted the first assignment. Please note again that ratification will only be given if you have done the work. I know who has done the work. You know if you have done the work. Please don't try to fool anyone. Okay, not yourself, especially not me. You'll get, yes, you will get the marks, and you should get them by tomorrow. They are out of 20. For those who submitted on time. For others, it's either from 16 or 12 or however late you submit. It depends on that. Okay, that is it for today. You guys can leave if you don't have any other questions. I will send you the audio very soon, so you can start working on them. Bye. Yes, Samarth? Wait,
I have a doubt. If we have larger data, then we can use an argument rest type equal to fast in librosa.load feature. So
yes.
when I use this feature in my laptop, I always get an error. And removing that argument, I don't get that error. Is there any specific reason to resolve that?
Share a notebook with me where you're getting the error and show me what the error actually says. Okay?
Okay, sure, I will.
Yeah, I'll tell you exactly what the problem is.
Okay, thanks. Bye.
Bye.